Okay, so we just finished machining these plates right here with our tap size for a 2-inch UNC. So I'm moving on to the larger plates, these guys down here, the 27 by 59 plates. And I'm getting the flex bed set up right now to accept these work pieces. So let me show you where I'm at. Thought I would go ahead and fill you in on what we're doing. Since there's only 2 of these guys, it's pretty simple to be able to set these plates down on the machine and tram in the side and then find the corner. I may end up putting a work stop up here, but for now, this is what I've got set up. Got these large parallels right here, and this black line here will indicate how far from the end of there that plate's going to be sitting. So I'm just going to have it centered on these parallels. We've got a couple of toe clamps holding them in place so that they don't move. And I use my machinist square here to get them nicely squared up here with the bed rails. And then I actually have these positioned center so that whenever we do our machining, we're going to be having a 5/8 hole pattern in all the 4 corners. And this will straddle in between the hole pattern, so the holes will be on either side of the parallel on both sides right there. And then probably what I'm going to do is end up using possibly some clamps like this. This is some of those Lenskys. I believe it's the Lenskys. Let's see. Yep, Lenskys. We got these. I've got some bigger ones there as well, and we may be able to clamp, because really what I want to do is kind of reach over the plate. It's going to be hanging over this parallel just a little bit, so we may go with the larger one so that we can reach over the plate and actually clamp down on top of the parallel there, not out here where it's overhanging. But I needed to do that because the holes on these plates, I'll show you, here's our print for the bottom plate. You can see how close to the edge of the plate our holes are. You only got about 3/4 of an inch. Well, it's 3/4 from the edge to the center of the hole, so they're going to be right out on the edge of the plate. So we have our parallels going right between the hole pattern there. So you got 7 inches center to center, and we got our parallel sitting right there. All right, so that's what I'm working on. I'm going to continue to get this guy set up. We still got to get him up here on the table and get them clean. I still got slag under the bottom, and I want to get them cleaned up like we did these guys right here. So I'm going to keep working on that and bring you guys back whenever we make some more progress on our setup here. I have been absolutely loving my new earth chain magnet there. This is the ELM 600, good for 1,300 pounds. And I was going to mention the weights of these earlier and kind of forgot about it, but I had this written down, and you guys can correct me if I'm wrong. We got 1.25 inch thick material. These plates right here, I've estimated weight about 578 pounds a piece, so right around 600 pounds for each one of those. And then the ones that's got the 2-inch holes in them, those weigh about 256 pounds a piece. So those aren't too bad. So we could technically lift both of these steel plates if they were like clamped together with that one magnet right there, but not going to do that. We're just going to do the one. So what I was mentioning before, what I love about this thing is that I can position it where I want to and then engage it with this handle. My dad's old Magmate, which is tried and true and we used for many years on a lot of jobs, it gets the job done, but you have a little bit more muscle that you're having to use to get that thing positioned into place, because there is no on and off. It's just a cam lever that picks one side of it up off the material, then you have to pick it up off there. This one just allows you to set it in place and maneuver it where you want to and then engage it. So it just makes it a little more convenient there. So we've got it centered up on here, plus the weight of the Noga and the camera on that side. All right, we're up. And then what I usually do is I just try to jar it a little bit, bang it around. And it's not going to come off there. We're going to set it right over here on the table so I can get it cleaned up. We'll just be doing one at a time. I really don't have enough room to put both of the plates up here, so we'll just do one and then work on the other one. And I think what we'll do is go ahead and hang, gotta move my tools over here. We'll hang this right side off of the table. And then the front side, we'll hang it off there as well. Then I'll just rotate it. There we go. I'll just leave that there. Get two sides cleaned and then rotate it and do the other two sides. Well, we successfully got her flipped over. You can see how nasty and dirty the bottom of it is. I think a lot of that's just from the table that they burned this plate out on. I'm sure they got a big flame cut table. I believe it comes from Sable Steel, is who usually cuts this stuff out. Just go ahead and get some of the dust off of it. And I know it's not ideal to be doing cleanup work like this around your machinery, but this is what I have to work with right here. So it's something that I accept because I have my crane in here, I have my forklift right here. It's easier just to do this right here in the shop than it is to try to do this outside in the rain and the heat and without the jib crane here to help me get it done. Definitely not flat. I think I have the plate where it's going to work right there. I ended up going a different clamping method than what I had originally planned. It just really wasn't working out. So I've got the plate shifted over that way so that those burnt out holes, the one in the center is lined up with this rail right here. And so I have a stud and a strap clamp on both sides of that right in the center, out of the way of everything. Now I've got some Sharpie marks here indicating about where the holes are going to be drilled, and you can see where they're at. The problem I was having whenever this was slid over here, even centered up on those rails, I was going to try these large Linsky's clamps, you know, go in there like so and clamp it down. But the problem is where this was shifted at is that this hole right here, and of course that one there, the clamp was right directly over where that hole is, so that wasn't really going to work out. Now we could do it like this and put the links keys clamp like right in here somewhere. The problem that I have with that is that you can see how close to this hole it is, and it's still kind of close to that one too. So I would rather not be so close to a clamp and a stud and a nut up here where that hole location's at. So I was trying to come up with another easy solution, and that was the simplest way to do that. I would rather have 4 clamps, but honestly, we're just drilling and tapping holes. You know, we're going to be doing a little chamfer on there, but I don't think that all of the downforce that we're going to be putting on that is going to make this plate shift around with those 2 clamps torqued down the way they should. So that's what we're going to go with. I'm going to see about adding a couple of work stops, maybe to the back and maybe on this end here. We'll see if I can get those to work. But if those don't work, since we only got 2, it's really not a big deal to set it on here. We'll tram in the side, get that nice and straight, and then we'll find the corner here, and then that'll be our work coordinate location, working off of that side. Okay, we need to go ahead and get this plate indicated. We need to make sure that it's nicely aligned to our x-axis. So I thought we would do this a little bit different than I've traditionally been indicating on here. Normally we attach an indicator to the spindle and then use the gantry to run up and down the parts to indicate. Always works really well. But let's try it another way. I've got more of an old school machinist tool over here that we're going to use, and that is the Starrett number 57 surface gauge. We're going to use this as a reference where this plate is at right here. We're going to be able to run this surface gauge up and down this bed rail here and use the pointer of the scriber to just kind of visually see how far away it is from end to end. Once we get it kind of close with our scriber, we'll actually take this off and we'll put a dial indicator on here and use it in the same manner. We'll set up a dial indicator and we'll be able to run this surface gauge up and down the side of the plate here and get it bumped in, just like if we was to use the gantry to run the indicator up and down it. So how we're going to do that on your surface gauges, you have these 4 pins that push through, and what we're going to do, I'm just pushing that back when it's kind of sticking down a little bit. They have a there's like a little spring inside there that gives it tension. So we're going to push the front pins down on the surface gauge, and this is going to serve as like a fence, a guide to guide the surface gauge down this rail here. All right, so the inside of this rail was actually machined. Whenever we set the machine up, we actually milled these to size. So we have a nice machined surface on the inside of the rail. The outside of the rail has not been milled, but it's probably pretty close to, you could use that as well, but we're going to use the inside of the rail. So with our pins pushed down, we can set our surface gauge. Let's just make sure it's clean. And I just wiped it off, but we'll wipe it again, make sure there's no dust on it. We can stick our surface gauge right there and just run it back and forth down the rail. All right, now we'll take our scriber. Let's go ahead and get it over here. This is just going to be our reference for right now. Kind of position this however you need to. How about something like this right here? Get it kind of close. We do have a fine adjustment on the number 57 as well. Down here on the base, you have this knob that's going to be your fine adjustment, so you can raise and lower it as you need to. So we'll put it back on there. All right, we're going to, let's see. Let's go ahead and raise it up a little bit. We're going to run it down here. Now I do have a little bit of an opening right here on the rail. This is so you can drop in a T-nut, so we can actually straddle that right there and get in a little bit closer. So we may do that as well, but just about the same, just going right up to that edge, just like so. And now we're just going to go ahead and use our fine adjust and run this pointer or scriber right up to the edge of the plate. All right, so now we're scratching that side right there. And then what we can do is just run this down. All right, and the plate on this end is actually going that direction, so we are crooked. And if you run this all the way down to this other side, we have a little bit of a gap there. It may be hard to see there, but we got about 1/8 of an inch gap. So we're somewhere, you know, around 125 thousandths or so push that way, just right here, probably a little bit more as you get a little further down. So now that we have our reference where we can run this back and forth, and it's just touching right here, so what we'll do is just go ahead and run the scriber down to this side, our surface gauge. Now we can start bumping the plate this way and try to get it to just kind of scratch the surface on both ends of the plate to get it pretty well even. And then we'll take that out and we'll put our dial indicator on there and bump it even closer. I've added a heavy duty C-clamp here to give me something to hit, just because the other side of the plate is so far away. I'd like to be able to stand right here and see the gap as I bump this plate around, okay? Just gonna, let's see how it reacts first. Yep, I can see it moving over, so just gonna make sure that our surface gauge stays there. Now we're scratching this side there as well. So we'll slide her down here to the other side and compare it. And it's scratching this end about the same. So it looks like we've got it pretty well even from end to end right there with our surface gauge. Now we can go ahead and put our dial indicator on there and then check it with that. So we'll just go ahead and take the scriber off of here and just kind of get it out of the way. We don't have to, but that way I don't have to risk running my hand into it. So we have this attachment here. This is the 57S, Starrett 57S, and it's a universal snug that'll fit on the surface gauge rod right here, just like so. And you've got a few different size holes in there for different stem sizes for all of the different test indicators. So we're going to use our Starrett 196 back plunge indicator here, and we can just simply slide it up through the hole that matches the rod there, and we're going to hang it in a manner just about like this. We'll have to get it adjusted once we get it on the mill. And then now we can use this like we did our surface gauge, our scriber I mean, and run this up and down the machine and take direct readings with our dial indicator there. All right, we're going to take our surface gauge utilizing our pins just like before. Set it down on the bed rail here, pushed up against the inside of that rail. Now we can adjust our rods here to get the indicator over a little closer. We'll tilt that one down a bit more and then loosen up the 57S snug. Get it kind of close like that. Now we have our fine adjust that we'll use to adjust the indicator. I'm going to twist that around just a little bit more. All right, about like that. So let's go up against our workpiece, and we're going to use our fine adjust. Dial it into 0. Now we can keep it pushed against the rail and slide this down, taking a direct reading. So how close do you think we got it? I haven't bumped it since I used the scriber, and I just slid it down, and it looks like we are, I don't know, that's showing about 7 or 8 thousandths low on this side. So let's slide her back down. All right, there's our 0 point right there. So that's all we got to do is just use that guy in this manner right here. Now keep in mind, we are indicating a flame cut edge, so that is not a perfectly flat, smooth edge there. All we're wanting to do is just get it referenced about as close as we can from one end to the other, being on the same plane there, and our same plane being a 0 on our dial indicator. All right, so we'll be able to take our hammer and just go ahead and bump this clamp again, and we'll try to get as close as we can, 0 and 0 on our dial indicator. All right, let's get our reading and see how close we got it bumped in there. Go ahead and slide this down, and you don't have to run it all the way down like, you know, on the face the whole time. You can just bring it down here and then just bring it right back in. Remember, we're going to this line here as our reference, so we're just kind of using that area. Looks like this side's 2 or 3 thousandths high, so that's an easy fix. We'll just take and bump this corner right here a couple thousandths back, and then we'll take another sweep and see where it's at. All right, let's take another sweep and see if we've got it dialed in there. We just bumped it here. Tried to move it about 2 or 3 thou. That needle is hovering all over 0 there. You got some high and low spots, but I think we're averaged out really nice. So if we just take it and just keep it pushed in there, and let's just kind of see where it's at. You can see that it's just bumping around a little bit. You got a little bit of a low spot right there. As we come right back down here to our edge where we started, right there about on the 0. So I'm gonna call this guy indicated in. That worked really nice. That was super easy using our surface gauge, and we didn't have the gantry down here in our way as we're trying to get this plate bumped in. So I think this is good to go. I am gonna see about maybe adding a couple of work stops on the back side and then maybe one on the end here. I'm gonna see if if I can get those set up and work. That way our next plate, we should be able to just kind of bump it right about into the same spot if I can get our work stops in there. Okay, we've got our 2 clamping studs torqued down nice and tight, and I've got our work stops set up now too, and these all work pretty good. That shorter angle plate worked perfect for this side right here. We got it pushed up against and tight, and then we got some V-blocks on the back there that worked out pretty good. Let me show you those. This pair of V-blocks that I had in the box just worked out perfectly. Just everything aligned really well, so this was super helpful. Just went through the casted hole there and clamped it down. We've got it pushed up, so we have 2 of these to be able to push it back up against there. Nice and tight. This guy is ready to go. So this is gonna be our origin point right here. So, you know, we'll touch off here for our X0 and then touch off over here for our Y0. Okay, we got our Heimer 3D probe installed. Let's go ahead and touch off. So this is gonna be for, I'm gonna use G56 for this work offset. All right, we'll do X first. Just about got to use some binoculars. It's so far away, but I mean, that's close enough. That looks like it's about on 0, so I'm gonna hit X for G56 right here. All right, I have our X zeroed out right there for that side. We'll back it off. We're gonna Y. Would be good enough. All right, let's bring her in. I'm gonna slow her down so I don't crash it. There we go. Let's go down to tenths. All right, looks close enough. I'm gonna hit Y for our G56, set position. All right, there's our X and Y done. Now I'll just take a tool, probably use our 17/32 drill bit, and I'm just gonna bring it down and touch it onto the work surface using a piece of paper. But before we do that, let's go ahead and easily back this out. We're in Y, so I wanna go back, get it off there. All right, then we're gonna go up and Z. Just like that. You bring it to me and take it out. I have our 17/32 drill bit loaded up. This is the drill we're gonna use for the job, and we're just gonna do the old school trick. We're gonna touch the face of the workpiece off here, but we're just gonna touch it to that piece of paper. I've got it really close, and I'm just using the incremental jog distance of 1/1000, and we're just gonna come down until it gets tight on that paper. So every time I click the button, it goes down 1/1000 of an inch. Let's do it like that. Now I can feel it getting closer. I usually, once it gets to about there and it starts getting tight, I go down about 1 more click. and that'll be close enough. So that should be within maybe 2 or 3 thousandths of this work surface. And keep in mind, this is a hot roll plate, so the surface is going to have a little bit of waviness to it. We're just trying to find a nice, just a nice average. We have a clearance of 200 thousandths, so all the tools come down to 200 thousandths above the surface there, and then it begins its feed at that point. So this is going to be really good right there. So we'll go into our, I need to go to my work offset. It's going to be G56. And we're going to Z this right here, subtract the length of our H19 for our tool 19 right there. I just ran through my typical air test with our workpiece there, and everything looks good. I've double checked my program, and I even made an adjustment. So for our retract height, which is, it's going to come up between each movement, I set that to 2.5 inches because I wanted to be sure that I clear these guys right here. This is a little under 2 inches, so 2.5 should be enough clearance to shoot over that and not worry about our tools hitting it and breaking it. So I made that modification, and everything looks pretty good. I did want to do a quick little run through of the cutters that we're going to be using on this job here. So let me show you that, and then we'll start making some chips. We might have to wait a few more minutes on making some chips because we got a huge thunderstorm about to roll through. There's a lot of lightning, and I don't want to risk the power glitching on us in the middle of a program. So I'm probably going to wait for that. I feel bad for all the people out on the beach because today is the big Blue Angels Air Show, and they expect about 150,000 people out on the beach. And you might be able to hear that rain coming down. They're getting hit with lightning and thunder right now too. So anyway, I wanted to show you this. So this is my drawing that I made, and you can see where all of our hole locations are. This is going to be our origin point right here. This is where we touched off our Heimer probe, and it'll actually start on this corner though. So very simple program. We're going to spot all the holes, and then it'll grab a drill, and we'll drill all the holes. Then it's going to grab that same tool that we spotted it with. It's going to chamfer all the holes, and lastly it'll grab our 5/8 tap, and it'll tap all the holes, and then that'll be it. All right. So the cutters that we're going to be using, I wanted to show you what we're going to be running today. I got a couple new cutters to do for this job right here. Our drill is going to be the Chicago-Latrobe reduced shank drill. This is high-speed steel, 1/2 inch diameter round shank there. You got a 118-degree split point, and I do have 2 of these. These are inexpensive when you compare them the price to a solid carbide drill. So I got a couple of these, and we're only doing 32 holes. It should last for many, many more holes than that. And then, you know, these kind of drills here, I can actually regrind them myself because I got a little drill grinder. So anyway, that's going to be our drill bit. For our tapping, I've got a couple of these new Cleveland. We're going to be running the spiral fluted tap today. So technically I can use the spiral point tap, but these were in stock, and I went ahead and grabbed a couple of these. So this is what we're going to run right here, the Cleveland 5/811 spiral fluted tap. Now for the spot drill and the chamfering, I have both of these 3/8 diameter drill mills are in the machines, so I don't have one to show you, but I do have a 1/4 inch diameter, so this is the same thing. This is the YG brand, and I just call it a mill drill. So you can use it to spot holes, drill holes, chamfer. This is a 90-degree angle on there, and you could also use it for side milling there as well. So it's a pretty versatile tool, and that's what we're going to be doing to spot our holes and chamfer them. All right, so that's our cutters. That's the 3 cutters that we're going to be running today on this program. So I'm going to wait for this big bad thunderstorm to move its way out of here before I start this program. And when I do, or when it does, we're gonna get started making some chips. That storm's still moving through, but I decided to make one more air cut on this because I made a little adjustment, and I went through the complete cycle this time. And so to machine this part, we're looking at 15 minutes and 8 seconds, and that was with our first tool preloaded in the machine, so it didn't have to do a tool change whenever it first started there. So 15 minutes is what we're looking at, so I think that's pretty good. I think we're ready to start making some chips. That big thunderstorm has moved on. Doesn't sound like it's right next to us now, so let's get going with this. I have adjusted our Z, so we should be down on our work surface now. And in between the drilling and the tapping cycle, I got an optional stop. We'll go ahead and clear the screen if we need to, the camera, so that you guys can see it a little bit more. But our chamfering, our spotting and chamfering, we're not going to run coolant, just our drilling and our tapping. So, all right, let's roll with it. I'm going to sneak up on this and make sure that we are on our proper Z dimension, so I don't crash any tooling. Just going to bring this down slow, just to verify that we're good on our spot. Should come down to 0.2. Okay, that looks good. I've got 100 thousandths depth on that spot. We're going to go back up to our 100%. All right, here's where we check our clearance height. Okay, it's good. Got about a half inch clearance over the top of that flange nut. Everything is looking great, guys. This is our 17/32 drill bit, tap size for 5/8 11. Oh, I'm gonna, all right, I'm gonna stop it here because there's one thing I did forget. I need to go in to our manual controls and turn off coolant interrupt. There we go. Walk this over and make sure everything looks good to go. We are doing a PEC drill cycle here too, so it'll break the chips. All right, it's looking good. All right, good clearance over our flange nut there. Chips are looking good too. That drill's doing a good job. In case you're wondering, we're running that. I believe I had it set at 90 feet per minute. So it's running 600 and right around 650 RPM. And I believe the feed is either 7 or 8 thousandths per revolution is the feed rate on that. Looks like our flood coolant's doing a good job too, getting down into that hole. Everything's looking good. I gotta say, somebody like myself that's trying to pick up on the CNC stuff, and I'm learning how to do this. It really is pleasurable being able to stand here. Once the program is running correctly, you know it's good. It's just nice being able to stand here and watch these cutters make all the movements for you. And I'm not having to crank the hand wheels, line up our zeros, and then hand drill it by pulling the quill handle there. It is really nice. Got a lot of programming and setup that went into this, but that's included in the job price. Once we get everything set up, we're talking 15 minutes per part. So they'll be finished fairly quickly. All right, that concludes our drilling. I'm gonna just, I'm gonna go ahead and go into manual so I can check this out, make sure our camera needs to be, doesn't need to be cleaned. If it is, we're gonna do that. So that went really well. Those chips look really nice in there, nice, pretty, shiny chips. I'm happy with it. So we'll clear the screen and we'll continue on. Next one is gonna be our chamfer. All right, so this is our 3/8 diameter mill drill that we're gonna use to chamfer the holes. I'm gonna run this down slow like we did our drill just to make sure that everything looks pretty good. So we'll just run about 50% for this first hole. Okay, that looks good. Let's bring it up to 100. That is beautiful. Doing such a good job. All right, another beautiful cycle. We're just gonna go ahead and continue on. All right, let me slow this guy down, bring it down here. So I wanted to remind you that we are using the Techniks MicroFloat tool holder and our Cleveland Cleveland tap. So we're gonna go ahead and let it rip. Looking good. Running at it 300 RPM. I got it set to go 1/4 inch below the hole. That should clean it up all the way through it. And it looks like our flood coolant's working good too. The MicroFloat tool holder, I went that route for these jobs like this just to kind of help assure that we have beautiful, perfect threads every time. That tool holder is going to give the tool about, I believe it was about 40 thousandths of float there that it could as it needs if the tap is a little bit out of alignment with the rotation and movement of the spindle. Whenever we finish this, I'm gonna check to make sure the thread does go all the way through there. And if it doesn't, then we'll make a modification for our second plate. All right, well, that is it. You can see that we did not move down where I had it for, for our X position. That's because I had reloaded the program and I forgot to change the very last line of code. So no big deal. We'll just go ahead and roll with it. I'm real happy with how this is looking. Hopefully you guys got a good image of that. The tap looks like it did a beautiful job, and it was bringing the chips up and out of the tap the entire time until it reversed and came back up out of there. So I want to move the gantry down and get a little closer look at these guys. I am happy. So we're still at just over 15 minutes. This particular one is at 15:39. So looking good. We did forget to give the old measurement check on here and be sure everything was good to go. So our center to center distance is 7 inches. We just use our nice Starrett hook rule there and hook the inside hole, and you can see we are 7 inches. Here, we'll flip it over this way. Read a little bit easier. 7 inches. Everything is good. And then you can go from the edge to the center of the hole. Looks like it's about 3/4. Remember, this is flame cut, and it was just slightly undersized there too. This side right here is probably a little bit closer to being exactly 3/4 from the edge, and it looks like it is there. 7 inches. 7 inches. We are good. All right, we've got our second workpiece located in there. We've already got our clamps torqued down nice. I made sure that we were bumped over against those two work stops there and this end stop right here, this angle. So we're nice and flush against our work stop. So we should be in the same exact location. Everything is ready to go. The only modification I made to our program was that last line where it's gonna take the gantry down that way where it's sitting right now once it's finished. That's the only change I have made. So I'm excited to see this guy get finished up. I'm really happy with the way it's been rolling. And I probably won't get a bunch of video inside since we just showed the other one. It's gonna be more of the same. We might see the flex, you know, doing its thing on the outside as we're cutting this. But man, I am just so happy. I'm over here smiling because, you know, every time I get to do a CNC job, it just makes me feel good that we have a good finished part that's on size and I haven't messed anything up. So it's looking good. We still got to tap these guys. That's a separate video. We're going to be loading these guys up once we're through with these plates here and get those finished up there as well. So I'm ready to continue on, and let's get this job finished. I almost forgot about this. I wanted to give it the inspection with our surface gauge and our dial indicator. I wanted to just see what the difference was. We already got the rail wiped off. So let's see. Should be nice and straight. All right, so it's on about 31 thousandths on the dial there. Just a few thousandths. Looks pretty straight to me, so it looks like it's on about 33 on that line, or in this position, I'm sorry. I'll make down here again. And it's on about 30 right there, so only a few thousandths difference. That's good enough for me. Let's go ahead and get this out of the way and send it. I did notice on a couple of the corners, the plate sounded a little bit more echoey or chattery. And I'm sure that's because the plate isn't actually sitting perfectly flat on that parallel with just the two clamps that we're using to hold it down. But everything should be fine. Just a drilling and tapping, very little pressure against that with that chamfering mill. See if we get any kind of chattery sounds on that corner that we're about to jump to. Well, not that hole. We want to go to the outside. It'll be this hole here. Nope, nothing any different. Just the start of it as the drill gets full contact on inside the hole. Moving on to our chamfers now. running that chamfer mill at, mill drill we're using for chamfering. I'm running it at 6,000 RPM, just in case you guys are wondering. That's the max RPM for our Flex CNC, 6,000. Moving on to our tap cycle now. I got my phone in there trying to get a little bit of close-up video of that. Z0, come on X. Got it. Got it right that time. That is awesome. I am smiling over here. This makes me feel really good. I'm very happy with the way this has turned out. I really just couldn't be happier. I don't know what else to say about it. All right, last thing to do is just give it a check. I guess we'll start with our no-go side. Does not want to go. All right, go gauge fitting just like it's supposed to there. I'm sure it's redundant, but we'll do it anyway. Let's check one of these over here. As you can see, good to go. That tap, as that Cleveland tap, did a beautiful job on those threads. And I feel really good that we're running that MicroFloat tap holder made by Techniks to make sure that we stay aligned with the thread there as we're cutting it. All right, well, this job is done. The bottom plates anyway, that's what these guys are, the bottom plates. And so I don't know if I had mentioned it before or not, but these holes are actually for some casters. They have some extremely heavy duty casters that they are purchasing from McMaster Car that has this 7-inch spread bolt pattern on there. And I don't remember what the rating for these casters, but it's several hundred tons per caster. Supposedly the part that's going to be getting sat down onto this cart weighs somewhere in the neighborhood of 50,000 pounds. They've got some kind of big gigantic motor or something that they're going to be setting on. So they've got 2 of these carts that they're building, and I think one's for each side of the motor, maybe to move it out of facility. I really don't know the specs on that. But I'll see, so the welding shop's the one that's going to be fabricating the stand. I'm going to see about maybe getting a video or a picture or something of it whenever they have it all welded together, so that we can show you guys what it looks like after it's all finished up, ready to go to the customer. But my part is done for the bottom plates anyway. As I said, I've still got to finish the 2 top plates tapping the hole, but that is a separate video. You guys may have already seen that at this point, but that's the last step, is getting those other 2 plates tapped, and we'll be finished up. That's going to be it. We're going to wrap this up, guys. I hope you really enjoyed watching the video. I always enjoy sharing it with you, and maybe my little manual machinist trick there indicating that helped you guys out, and showed a little bit of some of the old school stuff that I like doing. But I'm real happy with the job. This worked out really well. Big thanks again to Kevin over at mechanicaladvantage.com for helping me with my training and making sure that as I build these programs like this right here, he goes in there and looks at it and makes sure everything looks good, and tells me if I need to make adjustments or changes or things like that, or something that he might see out of whack. So big thanks to Kevin for always having my back with these programs and checking them for me. But otherwise, we will see you guys on the next video.